Hello, welcome back. Who is going to go first? We have three interesting readings for today. It doesn't matter which order we go in. I guess we could go, oh, they're all recent. Okay, Marco, please. Um, do you mind joining the call so I can display you? That looks good. Floor is yours. Thank you. Why is it so hot again? Is it just me? Normal hot? It's me?
It actually is.
It's fine. It's warm. There's more. Okay, yes, there's one.
Alrighty. Hey guys, Marco. Today we're going to be looking at this paper, thematic LM, not thematic LLM. Little quick kind of overview of the agenda. We're going to talk, first revisit what thematic analysis actually is. We're going to talk about how LLMs can be applied to the process. We're going to be talking about limitations of kind of current approaches, how thematic LM fixes those, the ways that we evaluate our thematic analysis, and then findings from the system. So again, this is just kind of review, right? Thematic analysis from the paper, they call it a qualitative method for identifying underlying meanings within unstructured text. Yeah. Again, this is the qualitative coding first, and then you take those codes and you group them into larger and larger groups. You find the relationships between the codes. This is kind of the iterative process that you're probably familiar with. And the idea is, hey, well, LLMs are good at finding patterns within these kind of large corpuses of text, right? And this is really useful if we want to automate our qualitative coding or thematic analysis procedures. So the way that a lot of the tools are kind of structured right now is you have the raw data and you ask an LLM to produce kind of your initial codes for each entry in your, let's say you have a database with entries, right? You ask the LLM to produce codes for each entry. As it goes, it creates a code book and it updates the code book. And maybe, you ask the human, it's like a human in the loop kind of situation. And you repeat this process until you're satisfied with the results, right? One such example, I believe this is called Atlas. You can kind of see it here on the right where you say, hey, here's every single entry I have. Here's the code that's corresponding to it, and here's the relationship between the different codes. And then there are, you can either have the themes automatically put together with the LLM or not. But in this case, this was just to the kind of the onus of the groupings is up to the person or up to the reviewer. So there's a few kind of limitations with this approach, right? The first and most obvious one is if you need a human in the loop in the first place, this is a really big limitation if you're working with these really huge data sets, right? And maybe something like social media data sets. So in this paper, they worked with Reddit and with general kind of social media data. You can't really do this human in the loop when you're working with large data sets. Also, when you're working with a human in the loop, it's going to cause the LLM to kind of reflect the biases that you have. Where if you say, hey, give me a code, and the LLM gives you a code, and you say, oh, that's not really good. I want it to be maybe more like this. Then the LLM responds in kind. Maybe that's a little bit of an egregious example, but it kind of illustrates that the LLM is going to be influenced by your perception or by the reviewer's perception. Third kind of limitation is that let's say when you have a human team going through your coding, right? You iteratively work through the code book, right? You create your initial codes, you go back, you reapply, you change them over and over again. And the idea of this is that you're going to kind of converge at some point. You see where codes overlap, you see where maybe some could be absorbed into others. And that again is the whole process, the strength of the process. But right now, the way that the LLMs are applied is you just go in sequence. So even though the code book is updating over time, you're not going back and reassigning the codes when you make a change, right? So maybe there's going to be some, entry 0 and 1 didn't get really classified very well. Entry 50,000 was perfect, but that's after 49, 1,999 attempts. And then the last one, which was kind of not really mentioned super clearly, but I thought was a pretty important idea, is that LLMs are they all kind of think similarly because, okay, you have the internet and they're all generally trained on the internet, so they're going to be thinking in the same kind of vein, unless you have like Grok or something, which is its own beast. So because this is the question that I asked when we were going over this topic is, well, how do you find the right answer? And the answer to that question is, well, qualitative coding and, sorry, that should be thematic analysis, is very subjective, right? And that's kind of a strength, is that you can combine all these different perspectives from different reviewers and researchers and have them, again, converge, right? But when everybody thinks the same, if every single reviewer is an exact copy of the person before them, you don't really have much diversity of thoughts. So you're not going to have very expressive codes and therefore not very expressive themes. So here's the solution that the thematic LM team came up with. They said, hey, we're going to address these problems one by one, right? The first kind of solution that you can see that satisfies problem 1 and 2 is that there's no human anywhere in the process itself, right? There's no human in the loop. Primarily the human was used as an intermediary between the final code book and the code assigner LLM. This was also replaced with a code aggregator LLM. So this is just a giant series of agents that are used to satisfy particular tasks through the pipeline. The second fix, but this solves the third problem. What was the third problem again? Yeah, it was the sequential approach, right? So the reviewer now, again, is a direct replacement of the human. They're going to be taking this code book. They're going to receive the aggregate codes from the set of reviewers or coders that you have. They're going to receive an aggregate view of it. The reviewer is going to update the code book and then say, hey, guys, go back, recode everything with this code book. Let's go through this process again and again and again until I'm satisfied, right? And then once the code book is finalized, then you move on to thematic coding. So again, this does the qualitative coding and then the thematic analysis itself. And this is, I believe, the thematic part is it's not iterative. You're not looping through it. So that was the third fix. And then the fourth fix is to say, hey, we want to improve the diversity of our codes, right? We want diverse perspectives. This is going to lead to us having more expressive codes. So the way that we're going to do it is we're going to spin up, instead of just having one reviewer or 5 copies of the same reviewer, we're going to spin up, 5 instances of ChatGPT and then assign each of them a different personality, right? So you can say, hey, coder 1, you are a Republican. Coder 2, you are an indigenous person. Coder 3, you think that climate change is a hoax, so on and so forth, right? This was done for the coder agents themselves and also for the thematic coder agents. Any questions about this so far?
Is there a system we could try, like a tool?
I did not look. Like actual code to download, I did not.
I'm very curious. I'm intrigued by this idea. It's very bold.
Yeah.
I think a qualitative researcher would be very offended by Kabir's mention of this.
Yeah. I think we can talk about how the validity and what we think of it at the end.
I'm actually really curious to try this on maybe some of the data that I'm familiar with, like in Judge.
Yeah. So we'll get to that, how it was judged. So hey, we have this pipeline, right? And as you're saying, maybe we want some kind of way to tell if it's better or worse or equivalent to when a human does the coding itself. So they kind of grouped they had 3 families of criteria, right? They had credibility and confirmability. That's a $5 million word. Where they say, okay, we have this pipeline, it spat out some codes. Does this actually do these codes represent the data itself, or is it just like gibberish, right? The way that they did this was with another LLM, right? Again, as a judge. So they said, hey, I believe that this was cosine similarity or something like that. Or they just took an embedding of each of the codes, they applied it to an embedding of or they did like a similarity with the the data in question, and they say, okay, how good is it? How bad is it? Does it really fit? The second family was dependability, which is saying, hey, if another researcher, and it wasn't exactly clear whether they tested this with human researchers or with like agents, but if another researcher, quote unquote, follows the same coding process on their own, am I going to arrive at the same conclusions, right? If I have a team of humans and this pipeline and they go side by side on the same data, are they going to roughly spit out the same thing? This was also done with like a similarity based score where, hey, okay, you take the embeddings, you can look for like overlapping themes is what the rope score is. And then the final one is transferability. This is kind of like a more classic machine learning problem of, okay, am I overfitting to the data? Or if I take these codes and apply it to another similar data set, is it still going to make sense? The way that they did this was they just took the data, like let's say you have all your Reddit posts, you slice it in half. First half is what you train on and you create your codes based on those. Second half is your test set or your validation set, and you see how well the codes line up, and they calculate a score for that as well. Yes.
Just a side note, if you remember when we talked about qualitative analysis, this is exactly the set of criteria that I also gave you at the time for establishing credibility when doing qualitative work. So I think here they're citing the same paper that I used in that lecture to come up with these. These are all very established criteria for credibility when doing qualitative research. You can argue with their implementation here that it's sort of human out of the loop. That's a different story. But the criteria are, I think, what you should always optimize for yourselves too.
Yeah. Cool. I just wanted to throw in a little bit of an example of what you might see. So these are kind of at the very end of the pipeline, you have your themes that got output. There's also some other information about like related topics and also a sentiment score, which I thought was an interesting addition. Earlier in the paper, they brought up sentiment score as kind of a poor proxy of coding, of qualitative coding, if I understood it correctly. And also it's worth noting that all of these sentiment scores are pretty low. So this was generally a very negative data set, right? This was from, I believe, mental health concerns or people posting about mental health concerns on that. Yeah, so again, you have a theme and a description and related topics. And this is kind of at the very end of the pipeline, everything that got spat out. This is not the actual codes, like the individual codes for each data set or for each point of the data itself, but the families that got grouped too. So what did they find, right? Does it actually work? The findings that they had were, okay, well, sorry, I should talk about the methods first. They compared 4 different systems, right? What they did is they first took a single LLM, right? They had to do the initial like, sequential coding, and then that got grouped into families. The second one was with an iterative codebook. So instead of just doing it one shot, they said, okay, LLM goes through, you pass it over to your kind of intermediary agent. That spits back your code book. You go through, revise again and again and again until, maybe after like 5 cycles or something like that. And then you go through and do your thematic groupings. Then we have thematic LM with 1 coder and thematic LM with 2 coders. Right? So what were the findings? Well, with 2 coders, in pretty much all cases, this was kind of the best system in terms of those 3 scores, right? So in terms of credibility and convertibility, in terms of dependability, in terms of transferability. And these 2 tables are just showing the 2 different data sets. So you have the Reddit, which is the mental health data set from Reddit, and then you also have climate change from Reddit. Something else that was an interesting finding is that when they did, remember how we spoke briefly about the different like personas that you can give your coder agents? This had a pretty big effect on the themes that actually emerged over time. So for example, hey, when I have 5 identical agents, they generally tend to agree on everything. But when I have 5 individuals, they disagree, and therefore this causes new themes to emerge in the during analysis, right? So these were some examples of themes that did not actually get created with the kind of homogeneous LLMs versus what did get created with the heterogeneous ones. And also, I think it's worth noting that these are kind of more maybe controversial codes. Not controversial, but representative of controversy or disagreement. You know, just kind of when you take a look at it, right? Oh, economic impact, or what is your responsibility in terms of the environment, or skepticism of climate science, right? You can tell which agents influence those. And this is just another similarity score between when you have these different kind of families of agents or the personas getting applied, right? So when they're all the same, right, they tend to agree, right? If you don't assign it an identity versus if you assign it the same identities versus if you assign them different identities. I believe that this was a cosine score of the cosine similarity score of the themes? Question mark? Yeah, the codes and themes generated by the 5 coders with no identities given, so on and so forth. Any questions so far?
You know what models they're using?
It's ChatGPT 4 for all of them. So this was all the same LLM.
ChatGPT 4. Yeah. But what agents were they using?
I believe 4.0. What do you mean agents? Is it
in like what? How did they set this whole thing up? Like just like having the agents talk to each other. Like how do you like this is pretty recent tech, right? Pretty good.
Yeah. Well, there's no point in which the agents are talking to one another, right? All they're doing is they're getting the text, right? So you have your text input, they receive that, they spit out their codes. All those codes get crunched in by the code aggregator into like basically a big JSON file, right? That goes to the reviewer spits back out a new updated code, and then you go and repeat. The agents aren't talking, like coder 1 doesn't talk to coder I, if that's what you mean.
So that's an easy improvement to make to this.
I see. What do you mean, like?
I mean, the whole point is you negotiate disagreements between the coders and whatnot.
Sure, after you make the code, though. Isn't that, I mean, what when I as a human, when I did my coding, the whole point of it was to be double blind. And that was a big source of frustration for me, where okay, I can't go over it every single one line by line and talk it over with my buddy who's also doing it, right? We have to go and see if we individually converge on the same codes, or same assignments of codes given the same data set and the same code book. So I feel like that would muddle the waters in terms of how valid the coding is itself.
So once the code book gets updated by the whoever is doing this updating, don't you have to go back and recode?
Sure, yeah.
And do you always code the whole data set?
Yes.
You code the whole data set, negotiate disagreements, update the code book, go back, recode the whole data set.
Yeah, the coders don't like negotiate disagreements between themselves. I believe that's just the job of the reviewer.
After the coders have coded the whole data set.
Yes.
And then the reviewer gives them back the updated code book.
Yep.
And this happens until fixed point or
until I'm not exactly sure what the stopping mechanism is.
like a lot of like when you do this as a human, we talked about how you shouldn't do analysis at the end. You should do analysis iteratively.
Yeah.
So the coders, I would think, go to few interviews or whatever. Then this whole thing happens. Then they get an updated code book. and they code a few more and so on. So like I feel like they would code more richly the ones that they code next if they have some updated understanding of what they're
Yeah,
looking for.
I see what you mean. Yeah, there is no, it's like full cycles every single time.
Yeah, interesting.
Yeah, any other questions?
So it's really just a like pipeline.
Yeah, it is. This is a, yeah, it is. They didn't really introduce, I guess, any new techniques. I think the whole pipeline itself is an interesting way to say, hey, here are the current limitations of, qualitative coding. Here's why there are limitations. And I'm going to borrow stuff from the literature and put it together. Yeah.
I would say the evaluation is also like it could have been more extensive, like as a criticism if I were to offer something, because I feel like especially the table that you showed, they're comparing like a single LLM to an agent. And my assumption would be that an agent would be significantly better than LLM, even without them showing me that table. What would be more interesting to me is if they were actually comparing this to a human,
Yeah, I agree.
because that would offer some more, I would say, interesting insights rather than comparing what their pipeline is going to like a single
Yeah.
LLM.
So, sorry, I believe that was supposed to be the idea. Again, it wasn't truly clear whether, like, when you do the two in parallel,
Yeah.
whether it was a human or an agent on the other side. I would assume that it's a human.
Okay,
But that's what this is supposed to be.
I see.
But again, it's one value, right? I think
Yeah.
you can have like multiple trials of,
Yeah,
you know,
I'm saying like even in the method column,
Yeah.
instead of having just like a single LLM, single code for system one,
Yeah.
system two, they could also compare it to like the traditional human qualitative coding process.
Yeah.
And comparing credibility, dependability, transferability.
Yeah.
For the human against the system.
Gotcha.
That's what I mean.
So this Atlas TI, which you mentioned earlier, does this offer this functionality built in?
No, this is the limited one that's just like single LLM, and it spits out the codes like sequentially.
I guess an open source version of this where you use open hands and do a lot of this validation be a very popular thing. Be well received by researchers, I think.
It's interesting that you say that, because at the beginning of the presentation, like towards the beginning, you were like, oh, I don't know if, qualitative researchers would adopt this.
Yeah, but all the quantitative researchers that need to do quantitative research that they would otherwise not do at all
Right.
might enjoy this.
Right.
Very interesting.
Yeah. So that was the paper. I don't really have any thoughts on the pros and cons, right? I thought that as a pipeline, it made sense. I wasn't really sure where the science was. Yeah, I also thought one kind of thing that stood out to me is that this reviewer is also a single like bottleneck, right? So if there's something wrong with it or any bias in it, then that's a pretty, I think it'd be cool to have a team of reviewers, right? Or you have the same team of coders, also do review functionality.
So the open source tool you build using open hands on top of this could combine this pipeline with the thing we read last time.
Yeah, the reflection.
Yeah.
The reflection piece.
Yeah, so like you inject human annotations throughout all of this, right? As much or as little as you want, right? So you can give the research team the opportunity to validate, any and all parts of this, right? Throughout.
Yes.
That's it.
That would be a cool addition.
Yeah. Any other thoughts, comments, concerns? Okay.
One more. Can you go back a couple?
Yes. What are you looking for?
here. You shall never use vertical lines in tables. Some of you have told this before, but maybe not all of you. So this is an opportunity for me to remind you of that. Okay. There shall never be vertical lines ever in any of the tables in your research papers. Period.
No question, why though?
Well, let me do this at the end. But well, because I'm really ugly and not necessarily.
It's funny because in some tables in the paper, they don't have vertical lines, and some figures they do.
Yes, I was thinking, is the way that they had different viewpoints was each of the models was essentially told like this is like your viewpoint, this is your personality. But all the models were still trained on the same data.
Yep.
So it'd be funny or interesting to see what would happen if they were instead trained on like other sources of data instead of just one data.
Yeah. Or you have something like instead of 4 copies of ChatGPT, you have one GPT, one Grok, one.
Yeah, different data then.
Yeah.
That would be cool.
Also, so I like the different models idea. What I would add to yours, which is a great idea, is context, right? So research team members, you could point the different models, right, to your previous papers or to previous, things you coded or notes or whatever, like anything that they can learn about your view, right, about the subject, so that they could be steered in that direction. And different team members could point to different parts of context for this. So somebody should build an open source tool using open hands with all of this stuff that is usable by researchers. That would be pretty popular. So Atlas TI licenses are insane, right?
I don't know.
The rate paid for Atlas TI is really expensive.
I mean,
Do an open source thing.
yeah. Sounds like there's a better solution out there or a better way to do it.
And then get acquired by Atlas TI.
I like this.
All right, thank you very much.
Thanks.
Let's move on,
Okay, shall we start?
please.
Okay, so today's paper is talking about like how ChatGPT can be incorporated into the 6 step of systematic semantic analysis in the following section. And I will cover the research background, methodology, and key finding, and also a little bit of my critical evaluation of this study. So like in recent year, like several researchers has already attempted to use the generate AI such as ChatGPT Cloud for the systematic analysis. However, this kind of study has share like 3 common limitations. Well, first, none of them are like complete all 6 steps of the systematic analysis, and I will talk it later. And also, none of them like provide AI with research contextual information. For example, the research background, the theoretical framework, and third, they do not instruct AI what kind of the methodology standard should be followed at each step. So these 3 shortcomings from the research gap that this paper is trying to address. Well, in order to address this gap, this paper aims to develop a specific ChatGPT prompts guide for each step of the systematic analysis. This paper make 2 core, like they claim core contribution. The first is offer a complete set of promotes guideline, cover all 6 steps, and which can not only guide AI in conducting the analysis, but also can serve as like a guide or like training tools for novel researcher. And second, it's demonstrate how to familiar AI with research context, for example, like research background, theoretical foundation, and methodology requirements before the analysis begin. So which can help to reduce the human bias and improve the transparency and the traceability of the analyst. So before introducing the specific method, it is necessary for us to understand what is the 6 step about the semantic analysis framework. So on the left hand is the traditional one, and on the right hand is the systematic semantic analysis, which is the primarily focused on in this paper. So the key difference is like the traditional semantic analyst take a primarily inductive approach, which is actually like bottom up. And the semantic analysts use like an abductive approach, which is sort of like it involves kind of like a continuous dialogue within the data and the theory. So it's paying like attention to both pattern within the data and the like research question and theoretical framework. And the figure is the core theoretical like contribution or the flow chart of this paper. So on the left hand is the step 1, which is the familiarization. So which lists all the information that need to be fed into the ChatGPT or other generative AI, including like research focus, research questions, theoretical framework, or like philosophical stance, methodology, and like participant information and so on. And the middle section is like from step 2 to step 4 is sort of like each step has like a corresponding R like framework serving as a selection criteria. So like 6 R's for S2 is the like keyword section, and 6 R for the coding section, and 4 R for the theme section. And step 5 is the on the right side is the step 5, so which is the conceptualization, and step 6 is the conceptual model. The arrow lies at the bottom is like shows that the research purpose, theoretical foundation, and methodology like runs through every step of the entire process. And I will introduce each step like now. So the first step is quite like most like crucial or like most important innovation of the entire paper. So they also argue that the biggest problem about this previous study was letting AI to read the data without any like context, providing like it with no research background at all. So the purpose of this step is kind of like let AI to understand all the background information, and then ask it to summarize the process of the semantic analysis to confirm that they understand. So here's a screenshot. So where it works through the 6 step and explain what's the plan to do at each stage. And only after AI confirms they are fully understand about their context or like their research method, then this kind of like formal analysis will begin. And the logic behind it is like quite intuitive. So so we can just imagine like if we are hiring like undergraduate students as our TRA, so it is kind of like impossible for us to let them to do the research or do the data processing without telling them anything about our study first. And step 2 is the keyword selection, so which is the step unique to the systematic like classic which is kind of like a unique to systematic semantic analyst. So the ChatGPT was asked to select meaningful words and phrase from the database on the 6 R's framework. And the comparison result is kind of like interesting here. So the AI selects a large number of keywords that are very specific and sort of like a technological or context oriented, like pointing like precisely to this kind of like a practical function and issues of the app. But well, like human select or the manual select is sort of like fewer in number, but closer to the participant's subjective feeling, or what we call like a psychological feeling or emotional expression. And it better captures the user's psychological resistance. And they also believe that the two approach can complete with each other. With AI expand the breadth and the human input ensure the depth. Well, however, there's like a problem that people haven't like addressed or answered yet. So, if combining the two approach like requires a researcher to manually like review each of the output, that's the AI like results. Oh, sorry. So, like how much time or energy or efficiency does AI can actually save or like increased? So the paper does not provide a kind of like empirical data of this point, but I would like to leave it as like a open question. So what do you think? So in that situation, the AI can actually help a lot, like comparing to the traditional like human-based coding.
This feels a lot like discussion we were having earlier about this hypothetical open source competitor to Atlas TI. Because this is exactly an opportunity to inject a bit of human input into the process. Like the contributions, not the whatever agent technology, which is straightforward. The contribution is making this usable, having the workflow and the UI, make it easy for human researchers to intervene whenever they feel like they should intervene, like here.
Really?
This feels like this whole paper, right? What you're presenting feels basically like the instructions you would give any of the individual coder agents in the previous papers, more or less.
Yeah.
At least the first part.
Yeah, it's more like a guidebook. Continue with the, okay, so the third step is the coding. And the difference between even is kind of more notable, like here. The ChatGPT like create 6 codes while the human or manual process produce only 6. And the AI code was very specific and descriptive, such as the technology frustration, which makes their like meaning immediately clear at a glance. The manual code, however, like were kind of like highly abstract, such as appendice absorption. So this word summarizes the user's psychological states and carry the implicit influence about the flow theory and the affordance theory. So one important methodology detail is like ChatGPT was instructed to use abductive reasoning. So the code was largely based on common pattern finding the data. And in addition, this kind of like a 6 manual code followed a clear narrative thread. So here's kind of like a main difference in the coding section. And fourth step is kind of the theme development. The ChatGPT produced 4 themes where the manual process like produced 3. And the AI themes were very specific and like sort of like a particularly oriented. Resemble the catalog you might find like sort of like in the business reports. And the manual theme, by contrast, were highly abstracted and carry a sort of like a strong theoretical tone. And one important distinction between the two is like the 3 manual things follows an internal logical like progression, and the AI 4 things on the other hand function more like a parallel ones or parallel catalogs placed on the side by side. So that says like AI did identify like sort of like a dimension that was completely absent from the manual analysis, which is the accessibility and the inclusive shopping. So it's just like the manual analysts can indeed overlook some certain perspective, but they're just like a kind of like emphasize the like previous claim that AI and human could actually complement with each other. And during the conceptualization and the conceptual model phase, so let me talk about the step 5 first. So the conceptualization part. The AI produced 8 concepts, but many of them were nearly identical to the same name, like from the step 4, and indicated that the AI did not truly achieve sort of like a theoretical leap from the theme to the concept. And the manual process, well, in contrast, produced a complete like theoretical model called the affordance flow funnel with a clear logical flow, like connection the 3 concepts. So when it comes to step 6, which is the conceptual model, the author did not even present a detailed comparison like between the AI and the human one. So I would guess that it may suggest that like the AI performance at this stage is like was not strong enough to like provide a meaningful comparison. So these 2 steps point out to sort of like fundamental issues like AI performs like reasonably well at the level of data processing or other coding section, but when it comes to the task that require a theoretical like contribution of creativity and the ability to integrate the theory or idea, is still for a sort of like a significant short. And it may like represent as a current ceiling of like the AI assistant, like qualitative research.
I wonder how many qualitative analysis or interview papers have public transcripts sort of anonymized. Because if they do, you could just train the AI to act like the human researchers.
I would assume that's what Atlas TI does. I might be wrong. But like, I'm sure they're doing some fine tuning over.
Because they have all this user
Yeah,
interaction data.
exactly. So like maybe some RLHF or some reward modeling over the APIs that you have from traditional LLMs. Do you know Atlas TI has a paper?
Somebody should go intern at Atlas TI and implement all of this stuff.
Maybe let's build the open source tool Atlas TI.
But to your point is, like, the point of this paper is that the LLM generated themes are crap compared to the human ones.
And it's also lack of some of the dips in thinking.
That's right. So like you would want to do some sort of post-training to get them to be less crappy.
Okay.
So I guess the quantitative researchers feel vindicated by this paper. Thank you.
And also the discussion section of the paper like offer kind of like a fairly candid analysis of like both advantage and challenge that's using AI, especially in the same analyst part. So on the advantage side, AI can reduce human bias, like efficiently process a large volume of data, improve the consistency of the analyst, and also uncover like pattern as the manual analysts might miss. However, the challenges also are also here or equally apparent. Well, like AI itself also like carry a algorithm or bias, and which may like simply replace the human bias at some point. Besides that, the internal process of AI is kind of like, as we all know, like box model problem or model. So it might also raise some of the concern from the like researcher. And besides that, the researcher will also kind of like will also bring some of the bias like through the promote design section, and finally the reliability and accuracy also requires the human to verify. Well, at the end of the paper, the authors proposed a solution according to this kind of challenge include like providing a theoretical base for each prompt, like apply like traditional quality control such as like member checking and multiple rounds of coding, and also ensuring that the AI is like thoroughly understand or familiar with the research background during the first step. Well, finally, here's sort of my like personal thinking about this paper. Well, of course, the strengths of paper are clear. It feels like a huge research gap. It's highly practical and use like a reasonable comparative design. However, there's still sort of like concern that brings to me. First, the whole paper is talking about a single case study, and whether its finding can be generalized to anywhere or any situation or any kind of like model is still like unclear. And second, the AI clearly underperformance comparing with the like human analyst in conceptualization and the conceptual model section, but the paper does not discuss it like sufficiently and sort of like place more emphasis on the advantage of AI. And the third is kind of like the main is the original creator of the systematic analysis method and the author of the case study used, and also the first author of this paper. So I was wondering if there's some of the potential like conflict of interest that will bring to concern. And lastly, the paper claims that the AI can actually improve the efficiency, but it does not provide any like comparative data on the time cost or other like empirical results or finding here.
Yeah.
So yeah. Is there any question like based on the whole part?
I didn't get why you said that themes were crappier than
So my interpretation of the finding, previous slide or one before. Did you want? Yeah, is
One of the things in the prior slide,
First step,
yeah, it seemed like it found an additional, like, sure it has like different perspectives, but is it correct here? It seems like it just offers a different lens to the.
I know, so maybe my claim was too strong. I interpret the comparison here as saying the LLM themes are shallow descriptive things, surface level, and the human ones are much more thoughtful, they go much deeper, they talk about sort of theoretical mechanisms and whatnot. So sort of surface level versus deep
In theory tree.
and theory driven is what I interpret the distinction to be. So in that sense, me as surface level can still be useful. But you know, no serious qualitative researcher, I think, would be satisfied with that. And you know, similarly, you know, I kept pushing this argument about the value of theory and thinking more deeply and mechanisms and so forth. So that seems like, you know, like it's what the human one goes towards and not so much the AI one.
I thought the theory part would only show up in the, I guess, step 5 and 6, but I guess it starts emerging as soon as you start looking at things. Yeah.
But to my previous point, like this feels primarily a user experience problem, less so a technological problem. Meaning, like, you know, give the researchers an opportunity to inject some of their wisdom in the process, right? Maybe the researchers are aware of some of this theory that's relevant, whatever. Like, you know, have them give them a way to inject that into the process so that the AI can be smarter. Like, you know, surely the AI can do better, right? If you steer it better. So that's, I find this unsatisfying, right? Because like, it's not, they haven't tried, I think, hard enough to get the AI to be better.
That the AI didn't work doesn't mean the AI can't.
That's right, yeah.
yeah, and actually that's the first steps. The author is trying to add some of the theory, like when we want to inject in, but I don't know, somehow it's like sort of like failed. But I believe that the author must or like at first inject some of the theory like the affordance series or some of the series at the very beginning, but the AI still
okay.
like failed.
I see, okay, I missed that part, okay. So maybe that came too early or something, maybe it should come later again.
Might have to like remind the AI about like that.
Maybe Marco's, whatever, reviewer,
Yeah.
agent, remind the coders of the theory, whatever, like this feels like a user experience problem, workflow problem. Okay, thank you, I missed that they had done this already in the beginning.
So any other?
Somebody should build a open source version of this using OpenHats. I guess if it's only $120 a year to use Atlas, so. But Atlas doesn't do this either, right? So.
No, never used it, so I don't know how good or bad it is.
I mean, according to Marco, right, it's only superficial coding.
Yeah. The sequential thumbnail.
Yeah.
I have a question. So the paper that Marco presented, if I understood correctly, having like the personalities to the agents, like giving personalities or to the agents, something that helps describe or identities to the agents.
Yeah.
Introduced like more like better themes, like better representation of potential themes, right? And this paper just basically said that I can't remember how I said it, like the LLM was better because it reduces like human bias or something like that, or, like eliminates like human bias. Aren't those kind of contradicting each other that like, okay.
Yeah.
So like in typical practice, would you want As a first paper, I would have thought that like having large overlaps and large agreements on like the general agents, like the generalized agents, would have been good, because it would have shown that like those themes were like maybe stronger or more like prominent, but then the paper said otherwise. So do you want?
Yeah, I guess we didn't discuss enough what human biases the LLM would alleviate here, right? That's what you're asking.
Yeah.
Do you know?
Well, like, the author claimed that the human bias kind of finally come from, what's, about the, for example, the unconscious bias, but like using the LLM, it can like dig every detail from the data so that it could sort of like prevent this kind of bias, or like human unconsciously like forgot something. And this is what they mentioned, like human bias.
Yeah, so more like attention and whatever, and
Okay.
things like this.
Okay, less like perspective and more just like our goals kind of.
Right.
Okay.
Which makes sense.
Yeah.
Yeah, thanks a lot. This was interesting. Last but definitely not least.
Okay, the paper I'm presenting is called Scaling Hermeneutics, Qualitative Coding with LLM for Reflexive Content Analysis. So the paper is about how to use LLMs models to assist qualitative coding, and specifically how to do that without losing the interpretive depth that makes the qualitative research valuable. And I'll give a paper summary. So the paper first giving a context that qualitative coding is central to theory development in social science. Like we read texts and interpret them, and we assign category labels based on the code book. But the interpretive depth makes it like it's very time consuming and resistant to automation. So human coding can handle maybe a few hundred passages, but anything beyond that becomes very impractical. So now LLM are getting very good at understanding nuanced languages, and now offers the possibility of large-scale coding. So the research question here is how can researchers integrate LLMs into qualitative coding while preserving hermeneutic depth and rigor. So the paper makes 3 contributions. I'll quickly go over it. The first is it propose a hybrid workflow where human develop the codebook, and then it iteratively adapt the code descriptions for LM comprehension. And second is demonstration that prompt design, chain of thought, one code per prompt substantially improves coding fidelity. And third is through a case study. It gives evidence that GPT-4 achieves human equivalent in intercoder reliability on most codes in complex humanistic tasks. And the author pointed out before LLMs, there were 2 main approaches to automating contents analysis, and neither work very well for qualitative coding. Supervised machine learning requires large annotated data sets and cannot use abstract code descriptions. And unsupervised machine learning rarely captures researcher intended categories. And LLMs are fundamentally different. You can describe a task in natural language and no training data sets is required. That is like a big deal for qualitative coding, because it means you can directly leverage your codebook. And there have been several studies testing this. One study showed like GPT 3.5 outperformed crowd workers on political text classification and other found like GPT-4 outperforms both experts and crowd workers on political Twitter messages. So yeah, and here's the workflow, the hybrid workflow the author was talking about. Like the phase 1 is human aid, it's the reflexive content analysis. This part is purely human and completely traditional. Like there are 3 things happening here. The first is the codebook development. So like the researchers read the text and develop category labels that captures theoretically meaningful patterns. And second is intuition refinement. When you read more and more passengers, you like start to develop a feel for the data and noticing patterns that feed back into how you define your code. And third is the research question refinement. The coding process often reshapes the research question themselves. And phase 2 brings in the LM, but humans still in the loop. Again, 3 things happening here. The first is codebook adaptation. Like you take the finalized description from phase 1 and then rewrite them so the LLM can interpret them correctly. And this is very necessary because LLM are lack of all the implicit knowledge that human coders absorb through discussions and training. And second is codebook refinement. Like you test the LM on a batch of passages and read its rationales and identify where it misunderstands, and then you revise the description and then retest it. Sometimes fixing one problem could create another, so you just keep going. And third is validation against the gold standard. So after each revision, you measure agreement between the LM's output and then the gold standard from phase 1 using intercoder reliability metrics like Cohen's kappa. Like you only move on when the performance is acceptable. And there's also a narrow in the figure going back from phase 2 to phase 1 label re-evaluation of coding schema through interaction with LM. So because working with LM might reveal fundamental problems with the codes themselves. So because sometimes not just the wording, but the conceptual scope. So if that happens, you have to go back and rethink the coding schema. And then the author here did not do this in their case, but the workflow accounts for the possibility. And the phase 3 is fully automated, labeled LM text categorization. 2 things here. The first is the codebook application. The validation prompts are deployed across the food datasets. And second, scalable hermeneutics. Like you now applying the interpretive codes to thousands of passages that would be very impractical to code by hand. So that's what the paper titles mean, scaling up the hermeneutic process. And also it's worthy to mention that LM applies codes only. It does not participate in codebook development, theory building, or research design. And the author is very upfront about what you gain and what you lost with this approach. So what's preserved is humans still need to lead all the interpretive work. And actually, the process of rewriting code is actually adds a second layer of hermeneutic engagement. Like you are forced to make your implicit assumptions explicit. So while often like it depends on your own understanding of the code. And what's lost is the experiential learning that comes from manually coding every single passage. Like when you are reading hundreds of passages one by one, you develop an intuition for the data, and that matters especially for students and new researchers. And you might also lose the collaborative negotiation process because discussion often brought new insights, but the LLM doesn't do that. And what's gained is scalability. Like I mentioned, you can now apply codes to thousands of passages, and statistical power goes up and noise gets averaged out. And you get clear code definition through the adaptation process. So the case study of the paper is how Du Bois, he is a foundational Black American scholar and civil rights activist. It has been portrayed in New York Times from 1970 to 2023. And they extract 232 passages, average 94 words each, and 9 codes in 3 categories, probing Du Bois' legacy across scholarship, activism, and public memory. And the gold standard here is 111 passages, codes by 2 human coders, disagreements resolved by consensus. They would like resolve all the disagreements through the consensus discussion. And so what exactly does the LLM do in this workflow? It serves as a coding worker. For each passage, it reads the text and makes a binary judgment. And for each of the 9 codes, it also provides a written rationale explaining its reasoning. And these rationale serves 2 purposes. First is requiring the model to explain itself before giving a judgment. Actually, might improve the accuracy. And this is the chain of thought effect. And it also allows researchers to diagnose why the model makes mistakes, which will tell you what's the ambiguous, so that you can like think, you can like then fix them, description and retest. And they don't do is develop or modify the code books and generate the questions and negotiate ambiguous case. Their chain of thoughts prompt in 4 steps. First is the role assignments, like you tell the model what it is. And second is the code definition. You provide the code, the title, and detailed description. And third is the justification. You ask the model to explain the reasoning before deciding. And fourth is the decision in formatting. You control the output judgment in machine readable format. And there are, they use the author presents 1 code per prompt rather than like giving the full code books at once, because it would like dilute the model's attention. And they giving no examples to the LM and set the temperature to 0. Here are 3, okay. So the key insight of this slide is like the code description is written for human coders don't work well for LLMs, then the reasons here is human coders don't just read the code book, they participate in the development process and they bring the implicit knowledge from discussions and share the context. And LLM rely entirely on what is written. So I think that is implicitly understood needs to be make it explicit. And the word choice it really matter. Yes. They renamed the academic repute to out of the mouths of academics because GPTs misunderstood the word. And another very practical technique is using the word explicit and implicit to control interpretation scope. When the LLM is too conservative and missed cases, you will add the languages like clearly implied through the context. And when it's to over applies the code, you add the explicit, like explicitly noted. And other thing is constraints placed earlier are more likely follow, like positive instructions would outperform the prohibitions. And okay, how do the authors trust the results? The golden standard is 111 passages coded by 2 human coders and reconciled through the consensus. And all the LLM performance measured against this standard. So, and the metrics here is Cohen's kappa, like which measured agreements beyond what you'd expect by chance. And the author also reports AC1 and F1, but highlights an important warning that AC1 can be misleading for codes that appear in not that frequently in the data. And beyond that, and finally is the overfitting risk, like when you are iteratively refining the descriptions on the same 111 passages, you might end up telling the description to those specific passages rather than the code's general meaning. And key findings here, I'll quickly summarize it. Under the optimal configuration, 8 out of 9 codes exist 0.6 and 3 reach the human equivalent. And the one poorly performing code is also the hardest for human coders. And codebook adaptation make a clear difference, for example, like the actives code jump from 0.48 to 0.81 just from rewriting the description. And on prompting, having LLM to show their chain of thoughts would help. And 1 code per prompt outperforms full codebook, and GPT-4 would dramatically outperform GPT 3.5.
Can I just interrupt for a second?
Yes.
And so all of this feels very much the same as the paper was presented last week. Is that right? Can either one of you comment on this a bit?
Yeah, it seems very similar. I think they were very clear in their paper that they are looking at the annotation process, like they're specifically going to focus on improving the labeling aspect of it. And as a finding is that they found that their own understanding of the codebook was being evolved after they went through LLM labels and tried to fix them using the LLM analysis.
Isn't that what that light says too?
Yeah, so that's where it seems very similar from that.
Do you have a sense, if you remember the paper Anmol presented on Thursday? How this feels like very similar contributions here. Is that right?
I think so. Yeah.
Do you know if they cite this paper?
Need to check.
I think yours was more recent, maybe.
Yeah, that was January 2026. I will check that.
Okay, I'll summarize the main key takeaways. On codebook adaptation, make sure all implicit assumptions are explicit. Single word changes can shift performance substantially, and the process depends researcher understanding. On prompting, chain of thought and empirical prompting consistently help. Using explicit and implicit is a very effective way to calibrate how broadly or narrowly the model interprets a code. And on validation, just always validate against a human's gold standard using intercodal reliability. Don't just look at the numbers, like read the rationales to catch systematic errors of the matrix mix. And also don't assume that switching to a newer or cheaper model version will give you the same performance. And on appropriate use, it's best for large data sets where manual coding is it's impractical. So for small data sets, like a set of interviews, hand coding is probably just as very efficient, but large scale, like random noise from individual coding errors gets washed out by statistical power. So that's tolerable, but systematic bias, like the model consistently misinterprets a code in one direction, this is not tolerable, regardless of the scale. And yeah, if a code performs poorly, like the right response is to flag it for manual review, like not to force it into automation. And I don't have the pros and cons page, but yeah, I think the very key contribution here is the workflow, like the no matter what model you use or what prompt you're using, the human first do the theory, like they are the key of the qualitative works. Yes, and I think the authors just intends to convince the readers who are insist in traditional qualitative research, like those who may be still very skeptical of automation. This will help. Yes, that's it.
It's by the same author.
Same author.
Yeah,
Okay.
Different data set.
same author wrote the paper that I presented. Like that was the later contribution to this work. In the paper that I presented, the focus was on improving the structured error that the authors identified the models were making. So they conducted the whole error analysis manually and tried to feed that again through self-reflection. So that was the contribution there, which I think was, and the idea sort of emerged by looking at the findings here in this way.
Yeah, okay, so it makes sense that they feel so familiar.
Yeah, seems similar, so same one.
Yeah, thanks a lot. I really enjoyed these 4 papers somehow. It's been very informative. Like, if you've got something out of this, I feel like I've learned a lot. Somebody should build a tool. Like combining these 4 into one open source thing that uses open hands as the agent framework. Seriously, I think it'd be cool. All right.